Sweetie, do you want to just order now? Because I kind of need the table.
No, it's okay. He'll be here soon.
Sure. Alright.
I have such a dilemma.
Oh, it's okay. This happens to me all the time.
You have trouble buying a Christmas tree too?
What?
Well, I want this Christmas tree to be around 224 centimeters. I don't want it to be too over or too under, just around that. And I have this random sample from Bullock's Trees, but it's not the exact measurement that I want. And I want to be 95% confident that it's around 224 centimeters.
I think I can help you with that. Well, I mean, you said this was a random sample, so it looks like, we got all these values. And if you read the fine print down here, that means that it's normal, that the mean is 224 and the standard deviation is 0.060. So I think we're pretty good to proceed, but just in case, I made a graph of the data. It's pretty normal, don't you think?
It's pretty normal, but it's skewed to the right a little bit.
Yeah, I guess it is kind of skewed to the right, but I think we're good if we proceed with caution. So I guess we're good with our data. We're ready to do our confidence interval.
Wait, what's a confidence interval?
Let me show you. A level C confidence interval for a parameter has two parts. First, it has an interval calculated from the data, usually of the form estimate plus or minus the margin of error. Also, the second part is that a confidence level C, in which in our case C is going to equal 95%, which gives the probability that the interval will capture the true parameter value in repeated samples. So first we're going to look at our standard normal curve, which is going to represent all of the trees in Bullock's Trees. And our z-score for a 95% confidence interval is 1.960. So as you see, there's going to be 1.960 on this side, and there's going to be negative 1.960 on the other side. So we're pretty sure, 95% confident, that our true mean is going to lie within that area. Now the things on the side, those are our tails, and that's going to be the small probability that it isn't close to our mean, or that our true mean actually isn't in there. It's over there. So, yeah. Nah! So this green on top here is our formula for the confidence interval. But where do we get the values to plug into this formula? Well, let me tell you. First, recall that you have this pamphlet from Bullock's Trees, and it gave you a random sample of a bunch of trees. So there's 16 of these values, so that's going to be our n value, 16. And also, at the bottom of this pamphlet, it said that it was normal, with the mean of 224 and the standard deviation of 0.060. So the only value we need now is the z-star, but like I said last time, if it's a confidence interval of 95%, the z value is going to be 1.960. So now that we have everything, let's plug it in.
Plug it in, plug it in.
So now we've plugged in all of our values, as you can see how it's written in red. And then the next line down, we've calculated it out a little bit. Now the 224 in red, remember that that's our mean, and it's going to be plus or minus this value in blue, which is going to be our margin of error. So when you subtract that, that's going to be the shortest the tree will be, and when you add it, it's going to be the tallest the tree will be in our 95% confidence interval, which we've calculated. It's in the black. So it's going to go from 223.9706 to 224.0294.
Well, that's cool and all, but what does it mean?
What does it mean? Well, it means that the true mean height of a tree from Bullock's Trees is going to be between 223.9706 centimeters and 224.0294 centimeters. Now, isn't that pretty close to 224 centimeters?
Well, I guess so.
Yeah, I mean, I think if you go to Bullock's Trees, I am 95% confident that you will find your dream tree.
Well, thank you. I don't know what I could have done.
Oh, well, I mean, you could have just done this on your calculator. So first you turn your calculator on, and then you go to Stat, go to Tests, and we want to do a z-interval. So here's our data. The standard deviation was 0.06. Our mean was 224. Our n, our sample size was 16. We wanted a 95% confidence interval, and now we're going to calculate. And see, we got the confidence interval 223.97 to 224.03. See?
cool, but if you're really cheap and can't afford a TI, you can just use a Casio. You go to menu, then go to stats, and then you hit the test button, and then go to Z interval. You go to interval instead. You go to Z, and then it's a 1 stat, and then it's a variable, so you want 95. Then you go to 0.06, enter, and 224 was our mean, enter, and then our sample size was 16, enter. And then you just say you don't want any, save, and then you calculate, and you get the same thing.
Yeah, I guess you could do that too.
It's pretty much the same thing.
Wait, wasn't there a waitress?
Oh, maybe. But anyway, don't listen to her. Only losers have Casios.
Oh, hey, look, there's my dad.
Your dad? You were waiting for your dad?
Yeah.
Oh,
Who are you waiting for?
nobody. I gotta go.
Perfect.
Oh, that's great. You found your tree. Wait, this is an artificial tree.
Yeah, well, if you go to the store, it'll tell you how big it is. So this one was like 224 centimeters, so hey, it's perfect, and it said it on the box.
Great.